This issue of the story of how a fragile and seemingly insignificant in the cosmic scale of life has acquired boundless power. But first, it's imperative to trace the evolution of the concept of extraterrestrial life. In 1947, while piloting his small aircraft near Mount Rainier, Washington, businessman Kenneth Arnold reported witnessing a fleet of 9 objects swiftly traversing the sky. Arnold estimated their speed to be several thousand miles per hour and likened their movement to saucers skipping on water. This incident served as the catalyst for the explosive proliferation of the phenomenon known as ufology. Reports of flying saucers quickly circulated throughout the United States, leading to a surge in UFO sightings almost daily. The influx of eyewitness accounts eventually prompted the United States Air Force to sound the alarm, attributing the sightings to potential Soviet activity. UFOs, and by extension, the concept of extraterrestrial life, captured widespread attention, likely fueled by advancements in rocket technology post-World War and the ensuing space race during the dawn of the golden age of science fiction. The explosion of the science fiction genre primarily occurred in English-speaking countries. Some scholars attribute the genre's rise to prominence to the era of the Great Depression, when people sought sources of optimism amid challenging times. The narratives, unfurling within the pages of inexpensive magazines, provided an escape for many. These magazines began surfacing in the early 20th century, with one of the most renowned being Amazing Stories, established by Hugo Gernsback. Gernsback, an immigrant from Luxembourg, was not only an inventor and engineer, but also an editor. His significant contributions led to the naming of one of the most prestigious science fiction awards for English-speaking authors, the Hugo Award, in his honor. Throughout history, technological advancements have consistently shaped and continue to influence global culture. Belief in UFOs stems from various factors, including the accounts of purported eyewitnesses, a willingness to trust those who recount extraordinary tales, a tendency to disregard counterarguments, and a yearning to establish contact with other worlds. Philosopher Paul Kurtz suggests that belief in extraterrestrial beings parallels belief in the supernatural, viewing ufology as a modern mythos, reflecting cultural currents that seek to attribute humanity with ancient origins and imbue existence with profound significance. This inclination toward the transcendent is inherently human. However, what's particularly intriguing is the emerging notion counter to the existence of extraterrestrial civilizations. The concept of Earth's solitary existence in a vast, perpetually cold and uninhabited universe. This perspective suggests that we are fundamentally alone. Earth is deemed a minuscule anomaly, a mere chance occurrence. According to this view, there is unequivocally no other life in the universe besides us. Despite extensive efforts, including the use of numerous telescopes scanning the cosmos, no evidence of extraterrestrial activity or signals has been detected. We are the exception. We are alone. The popularity of this theory can be attributed to its resonance with the notion of the solitary nature of human existence. The progression of urbanization, the expansion of cityscapes, the rise of communal living spaces, and subsequently, digitalization gradually isolate us from others, from other forms of life. Despite this, the search for extraterrestrial life has thus far yielded no results. The question of why humanity has yet to encounter any extraterrestrial civilization finds its explanation in the renowned rare Earth hypothesis. However, before delving into the unsettling implications of this hypothesis, it's essential to grasp its scientific and philosophical backdrop. If you appreciate the content, please show your support by liking, subscribing to the channel, leaving a comment, and sharing this video with your circle. Your engagement greatly aids the algorithm. In 1950, physicist Enrico Fermi, who worked at Los Alamos on the Manhattan Project, wondered, there are untold numbers of stars and planets in the galaxy. The observable universe is 100 or even 200 billion galaxies. There is a high probability that technically advanced civilization should have arisen, mastered interstellar flight, and colonized the galaxy. But then, why have we still not seen anyone in telescopes or heard anyone in the radio band? More than 70 years have passed since then, and many answers to the Fermi paradox have been offered. The great silence of the cosmos is best explained by the rare Earth hypothesis. Supporters of the rare Earth hypothesis contend that despite the vast number of exoplanets within the Milky Way, conditions conducive to the emergence and evolution of complex ecosystems are exceedingly rare. Humanity, they argue, has won an exceptionally unique, possibly incomparably unique lottery. But what if this assertion holds true? But what is the basis for the assumption that we are not alone in this stiflingly hostile, beautiful universe after all? The concept of the hypothesized prevalence of life rests upon two foundational pillars, twin supports, if you will. The first pillar is isotropy, the uniformity of the universe, which remains consistent at the microscopic level in all directions. The second pillar is the Copernican Principle, positing that if a particular pattern were chosen at random, it's highly likely to represent a feasible possibility within the universe. Applied to cosmology, this implies that Earth-like planets ought to be commonplace throughout the cosmos. But what if the Copernican Principle doesn't apply in the case of Earth? Suddenly, the Earth belongs to a very rare type of planet. Given our capacity to observe the cosmos across various radiation bands without discovering any evidence of extraterrestrial civilization, the singularity of Earth doesn't appear far-fetched. The rare Earth hypothesis was expounded upon in the book Rare Earth: Why Complex Life is Uncommon in the Universe by paleontologist Peter Ward and astronomer Donald Brownlee. These scientists proposed that while microbial life forms may be prevalent in planetary systems, advanced life forms such as animals are far less common. They contend that on our planet, a remarkably rare and unique sequence of cause and effect events occurred, leading to the development of such a complex biosphere, followed by the emergence of consciousness, and more specifically, the birth of culture. Opponents of this hypothesis often reference the renowned Drake equation as a counterargument. The Drake equation, proposed in 1960 by Frank Drake, a professor of astronomy and astrophysics, aimed to calculate the potential number of technologically advanced civilizations within the Milky Way that we might potentially encounter. It purported to estimate the quantity of intelligent civilizations with significant precision, despite the complete absence of evidence of extraterrestrial civilizations. However, the formula's weakness lies in its subjectivity, allowing it to yield a wide range of results. Presently, we are unable to substitute exact values for most variables in the equation, due to our lack of knowledge. Nonetheless, as technology advances, scientists are gradually refining their calculations. For instance, it is now understood that there are between 250 to 500 billion stars in the Milky Way. In 2013, scientists postulated that there could be approximately 40 billion Earth-sized planets within habitable zones, with around 11 billion potentially orbiting stars, similar to the Sun. The absence of intelligent activity outside the Earth forced the mind to search for the cause of the universal silence. The answer was found in an instant. Highly advanced civilizations burn in the fires of self-destruction. To this argument, many people at some point come, trying in this way to draw attention to the existential danger of the production and accumulation of weapons of mass destruction. Beyond this, there is the possibility of the existence of the Great Filter. The Great Filter is a hypothesis put forward in 1996 by British economist and futurologist Robin Hanson, and it consists in the fact that intelligent extraterrestrial life forms must overcome many critical stages of development. Fundamentally, there exists at least one hypothetical barrier that scarcely any species in the universe can overcome to progress to the subsequent stage of development. Robin Hanson elucidated the milestones necessary for life to evolve into a spacefaring civilization. Firstly, a suitable environment is imperative, a planet situated within the habitable zone where life can thrive. Subsequently, life must evolve, with organisms capable of reproducing using molecules like DNA and RNA. From simple prokaryotic cells, evolution must progress to more complex eukaryotic cells. Adoption of sexual reproduction becomes crucial as it enhances genetic diversity. Further, evolution leads to the emergence of multicellular organisms, eventually evolving into complex life forms capable of utilizing tools. To attain the status of a spacefaring civilization, life must possess the requisite technology for space exploration. Subsequently, these spacefaring species should continue to colonize other worlds and star systems while navigating the peril of self-destruction. The point of the rare Earth hypothesis can be summarized as follows. The existence of a planet with Earth-like characteristics in the universe is incredibly rare. Rare because there are actually hundreds of different conditions. The probability of even one condition being met seems unlikely, let alone the confluence of hundreds of factors. First of all, the star must orbit the center of the galaxy in a circular path, since an elongated orbit exposes planets in its system to lethal doses of cosmic radiation coming from the densely populated galactic center. In addition, the optimal scenario assumes the presence of a metal-rich star, since metal-poor stars typically produce gas giants rather than Earth-like planets. Resource availability for an Earth-like planet is also an important issue. At the same time, the star must not be too hot. For example, stars such as Sirius or Vega, known for their high temperatures, turn into red giants in 1 billion years. Clearly not enough time for life to arise and evolve on a planet. As they expand, they kill all the planets in the vicinity. In our galaxy, only about 5% of stars resemble the Sun. For life to emerge, planets must reside within the habitable zone, neither too distant nor too close to their star, but positioned at an optimal distance to avoid extremes of temperature and radiation, an area often dubbed the Goldilocks zone. The presence of Jupiter, the largest planet in our solar system, serves as a shield against potentially catastrophic collisions with massive asteroids. According to one theory, the Moon formed from a collision between Earth and a Mars-sized planet called Theia, resulting in our natural satellite. The Moon's presence has proven highly beneficial, stabilizing Earth's axis of rotation and contributing to the generation of a robust magnetic field, which shields life from harmful solar radiation. Furthermore, a conducive climate is essential for life to emerge, persist, and evolve over billions of years on a planet. Additionally, like humanity, life requires discipline to thrive. Evolution often thrives in conditions that are not entirely comfortable. Even mass extinctions can catalyze new pathways for life. These upheavals force life to adapt to new challenges, leading to the emergence of entirely novel development trajectories. Planetary homeostasis on a grand scale remains elusive, prompting life to continually evolve in response to shifting environments. For instance, the dramatic extinction event that wiped out the dinosaurs paved the way for mammalian synapsids to fill ecological niches. Subsequently, the evolution of the brain and the emergence of consciousness gave rise to human language and culture. It becomes apparent that the emergence of highly evolved life forms necessitates the precise alignment of hundreds of parameters encompassing both the star system as a whole and the specific characteristics of the planet itself. Because of this, even on the scale of the Milky Way, the probability of a planet with a highly evolved life form that can sustain it, but also stimulate it, is virtually zero. It just so happens that we were born at this point. That's how the Earth was seen in 1990 by Voyager 1, which by then had flown 6 billion kilometers away from the Sun. The Dilemma of the Loneliness of Earthlings, the author of the novel Contact, a pioneer in the search for extraterrestrial life, astronomer Carl Sagan once commented as follows: "Human civilization is unimaginably insignificant even on the scale of the solar system, let alone the Milky Way or even larger star clusters. Are we alone as a civilization, or at least as life that originated on a planet?" Proponents of yes and no answers have reams of arguments, ranging from "if we're not alone, where is everyone?" to "we're so primitive we can't notice anyone yet." The Earth is unique in that it has been an amazing training ground for a special type of matter, to which man has given the name life. The stream of consciousness in living organisms was launched at one moment and began to gradually become more complex. The outcome of this development is a voluminous, multifaceted awareness and diverse understanding of how our home, planet Earth, came into being. In this large issue, myths will be intertwined with cosmogonic hypotheses. We will try to understand the people of the past and their unique perspective. In addition, we will understand how the emergence of planet Earth gave rise to many new worlds. To commence, it is essential to grasp the process of solar system formation, which has been elucidated by modern science. However, let us delve into various interpretations offered by notable figures of the past. We find ourselves in an era where naturalism as a philosophical standpoint, is gaining prominence, marking the Age of Enlightenment. Pierre-Simon de Laplace, renowned for the Laplace hypothesis, was a distinguished French mathematician, physicist, and astronomer of the late 18th and early 19th centuries. He gained renown as one of the pioneers of probability theory. His cosmogonic hypothesis of 1796 endured for an extended period, bolstered by its mathematical underpinnings. Central to Laplace's hypothesis is the notion that the Earth and other planets within the solar system coalesced from the rotation of a nebula. Laplace's premise relied on the balance between centrifugal force and gravitational force, positing that when these forces are equal, rotational instability ensues. Consequently, the original nebula would flatten, expelling dust and gas that eventually coalesced into planets. Prior to planet formation, this dust formed rings. Similarly, Immanuel Kant proposed the existence of an initial cloud characterized by extremely low temperatures. The planets formed through a process of condensation, as proposed by the philosopher. According to him, Earth emerged subsequent to the formation of the Sun. Kant's work on this subject, published in 1755, is known as Kant's nebular theory. As researchers would later find out, Kant's theory was largely based on the views of Swedish mystic and naturalist Emanuel Swedenborg, a man who 20 years before Kant argued the following. Swedenborg argued that under the pressure of cosmic matter, dense conglomerates, akin to embryonic stars, emerged in certain regions. Within these conglomerates, vortices formed due to the inherent spiral motion of matter particles. These vortices captured particles of different densities, creating a globular dark crust that orbited around the central luminous body, the Sun. Over time, the centrifugal force caused this crust to thin until it eventually ruptured, forming fragments that encircled the Sun in the form of rings. Consequently, this shattered crust fragments, giving birth to the planets. Thus, there was a point where it became evident that Kant and Laplace were essentially describing the same phenomenon. However, not all adhered to the evolutionary narrative regarding the origin of planets orbiting the Sun. In 1749, the French naturalist Georges Buffon proposed an alternative scenario. He posited that another star, passing near the Sun, caused a significant disruption. This stellar encounter generated a massive wave stretching hundreds of millions of kilometers into space due to the gravitational attraction of the passing star. As this wave broke away and curled around the Sun, it fragmented into clusters, each eventually forming its own planet. Buffon's interests extended beyond space. He also delved into the realm of human evolution. Remarkably, he anticipated Darwin by over a century, suggesting a theory of human descent from monkeys. However, Buffon's evolutionary ideas were met with widespread misunderstanding, leading him to burn his works on the subject. Subsequently, Vasily Vesenkov, an alumnus of the Imperial Kharkov University, argued for the nebular origin of the solar system. The Sun took precedence as the initial celestial body to form. However, in 1905, an unconventional collaboration between Moulton and Chamberlain led to the publication of their theory. Chamberlain, primarily known as a publisher of the journal Geology, was also involved in theories of glaciation and was the founder of a business centered around spring water. Moulton was a professor and did two things: ballistics and criticizing Albert Einstein's theory of relativity. Together, they put forth the theory of planetesimals, which describes the process whereby a celestial body gradually attracts smaller bodies in orbit, leading to the compaction of its core. Subsequently, astronomer James Jeans contributed to the discourse by suggesting that the formation of the solar system was prompted by the close passage of another massive star near our Sun. This event resulted in the gravitational stripping of matter from our Sun, ultimately giving rise to the planets. However, Otto Schmidt proposed an alternative notion, suggesting that it wasn't a star, but rather a cloud of meteors that passed by. Adding to the array of theories, Subotovich and Rudnick proposed in 1984 that a gas field nebula was transformed into our planetary system due to a supernova explosion. Nearly every theorist, from Laplace and Kant onwards, contributed valid insights. It is theorized that initially, our planetary system occupied the space once occupied by a colossal star named Kotlik, surpassing the Sun in size by 30-fold, named in honor of the Aztec goddess of fire and earth. This star underwent a cataclysmic explosion, giving rise to a vast molecular cloud. Approximately 4.6 billion years ago, the formation of the Sun commenced from this molecular cloud. As the cloud experienced compression, its modest initial rotation accelerated. Concurrently, the increasing density of matter at the cloud's center caused temperatures to soar. Eventually, temperatures reached millions of degrees, triggering a thermonuclear reaction, marking the Sun's birth. Within the remaining portions of the cloud, other compacted regions emerged, which eventually coalesced into protoplanets. At the onset of the 21st century, a prevailing notion among scientists suggested that the planets did not immediately assume their current orbital positions. Approximately 4.5 billion years ago, they orbited much closer to the Sun than they presently do. With the emergence of Jupiter possessing immense mass, the dynamics of the solar system altered significantly. Jupiter's gravitational influence led to the expulsion of asteroids into the inner solar system, bombarding the already formed planets therein. It's conjectured that these bombardments played a role in the appearance of water on Earth. During its nascent phase, Earth experienced intense heating. However, following the cessation of the bombardment period, the cooling process commenced. Initially, the planet's surface was molten, allowing lighter elements to rise to the upper layers, while denser ones sank deeper. As Earth gradually cooled, a solid crust formed, overlaying a still liquid mantle. The metals that had descended formed the metallic core, which presently generates the planet's magnetic field. This transformative process spanned approximately 10 million years. The Earth's atmosphere originated from intense volcanic activity, with gases venting from the planet's interior to the surface. However, due to the gravitational pull of the Earth, these gases were unable to escape, leading to the gradual formation of the atmosphere. As the Earth's surface gradually cooled, conditions became conducive for the formation of a crust. Approximately 30 million years after the Earth's formation, it collided with another planet, resulting in a significant release of energy. This collision caused both planets to merge and revert to a liquid state, ejecting a substantial amount of debris into space. Under the influence of gravity, this debris coalesced into a ring from which the Moon eventually formed. As the surface cooled, a crust formed and water began to accumulate, giving rise to the primary world ocean. The first continents emerged approximately 3.5 billion years ago. It's theorized that granitic continents may have drifted across the mantle over time. Throughout the Earth's formation, cycles of supercontinent formation and breakup occurred repeatedly due to the influence of the planet's internal heat. Around 3.8 billion years ago, active volcanic processes occurred underwater, facilitating the emergence of life. Under these unique conditions, the first single-celled microorganisms emerged accidentally. As conditions changed, some bacterial species adapted to rise to the water's surface and developed the ability to harness energy through photosynthesis. Extensive colonies of stromatolites thrived in shallow waters near the emerging continents. These algae produce significant amounts of oxygen. The increasing oxygen levels in the water and atmosphere played a crucial role in the evolution of multicellular organisms. Subsequently, a continuous process of evolution unfolded. Approximately 70,000 to 30,000 years ago, Homo sapiens began exhibiting remarkable behavior. Large populations of sapiens migrated out of Africa, displacing Neanderthals and other human relatives in the Middle East, and in some instances, engaging in genocide. In a remarkably short span of time, Homo sapiens spread to Europe and East Asia, and around 45,000 years ago, they voyaged across the ocean to reach Australia. They innovated, inventing boats, oil lamps, bows and arrows, and mastering the art of sewing warm clothing. Art, jewelry, evidence of trade, social hierarchy, and religion emerged, marking unprecedented advancements resulting from a cognitive revolution, the dawn of new ways to share information, and, more significantly, new modes of thought. The catalyst for this revolution remains unknown. The most common theory holds that random genetic mutations changed the internal tuning of the human brain, and sapiens became stronger in their ability to think and communicate using verbal language. This mutation is commonly referred to as the tree of cognition. Why this mutation occurred in Homo sapiens and not in other human species like the Neanderthals remains speculative, perhaps mere chance. Certain questions, despite our technological advancements, evade satisfactory answers. How did space, time, the universe, life, and consciousness originate? In attempting to unravel these mysteries, we are left with assumptions, hypotheses, and sometimes theories. In our context, what's more crucial is not deciphering the reasons behind the tree of knowledge, mutation, but understanding its far-reaching consequences. Our primary advantage lies in our remarkably adaptable language. Through the combination of a limited set of sounds and gestures and various permutations, we possess the ability to construct an infinite array of sentences, conveying diverse meanings. This capacity enables us to perceive, retain, and convey vast amounts of information about our surroundings. The emergence of legends, myths, deities, and religions can be traced back to the cognitive revolution. While many animals, including various human predecessors, could exchange basic factual information, it was the cognitive revolution that enabled Homo sapiens to develop a secondary mental representation of reality. This allowed for a specialized processing of information, wherein empirical perceptions were replaced by implied mental constructs, facilitating the mastery of abstraction. The notion of abstraction finds its roots in Aristotle's philosophy, where it is described as a method for selectively examining reality, involving the subjective mental division of the whole into its constituent parts. Aristotle posited that science investigates the universal, and abstraction serves as the means through which universals are apprehended. Hence, abstraction not only underpins scientific understanding, but also serves as the foundation of scientific inquiry itself. Aristotle further distinguished between empirical abstractions, based on observed phenomena, and theoretical abstractions, which are necessary when the apprehended thought and the thought itself are inseparable. As, for example, in mathematics, where knowledge and the object of knowledge are one and the same. The very fact that only Homo sapiens are able to talk about the seemingly non-existent, unperceived physical world is indisputable. We've acquired the ability to craft a shared mythology, encompassing narratives like the biblical creation story, the pre-primordial tales of Australian Aborigines, and the nationalistic myths of contemporary states. From the multitude of realities invented by humans and the diverse behavioral patterns shaped by these fictional constructs, cultures emerge. Every culture, from its inception, undergoes continuous transformation and advancement. This perpetual motion, this ongoing flux and progression, constitutes what we term as history. But why is fiction of such significance? Because it offers an escape from reality. In truth, it is myths that provide guidance to individuals, to human existence collectively, aiding in the resolution of existential dilemmas. Mythology influences goal setting and confers significance. The ancient archetype of the creation myth exemplifies this point vividly. To truly grasp it, we must navigate through the realm of myths to arrive at a deeper understanding. The creation myth, also known as the cosmogonic myth, recounts the origins of the universe and humanity. Across diverse cultures, the narrative typically begins with chaos, an amorphous void, devoid of structure. The Greek concept of chaos, signifying vast emptiness or abyss, embodies this primordial state. It represents the boundless darkness of formless matter preceding the genesis of the cosmos. In Judaic and Christian theology, the term chaos similarly denotes the gulf or chasm resulting from the separation of heaven and earth. In Norse mythology, chaos takes the form of an abyss known as Ginnungagap. It embodies an indeterminate realm of space and time. This primordial essence, inherently potent yet undefined, is often symbolically associated with water, the elemental essence traditionally linked with the feminine, or more precisely, the maternal. Ancient beliefs held that both the world and humanity themselves were birthed from a primordial source. Many envisioned this source as a vast ocean, possessing an enigmatic and infinite character. In Egyptian mythology, this primal ocean was known as Nun, described as a boundless, cold, watery expanse of darkness. For centuries, this ocean remained undisturbed until one day, the god and creator, Atum, emerged, becoming the first deity in the universe, destined to bring forth all things into existence. In Slavic mythology, the creation of the world from water was symbolized by the dove, which dived into the depths and retrieved the material for creation, then sowed the ocean with lands. Greek mythology tells of the emergence of the earth goddess, Gaia, from chaos, along with the birth of Tartarus, a dark abyss, and Eros, the embodiment of all-encompassing love. With these divine beings emerging from chaos, the process of creation commenced. From the boundless chaos emerged eternal darkness, Erebus, and dark night, Nyukta. From Nyukta and Erebus came eternal light, ether, and the joyful light of day, Hemera. With the emergence of light, it spilled over the world, initiating the cycle of time where day replaced night. Simultaneously, in Egyptian mythology, the motif of Chaos Kampf, or the Battle of Chaos, emerged for the first time. This legend tells of the conflict between gods, representing order, harmony, and chaos, war, darkness, and destruction. Among these gods were Horus and Set, or Ra, and the serpent of darkness, Apophis. The Egyptians believed that if Ra triumphed, the sun would rise, but if he were defeated, darkness would prevail. Originally, the serpent symbolized chaos, and later became associated with universal evil. Over time, however, the serpent came to symbolize fertility, immortality, rebirth, and desire. Particularly popular were myths featuring sea serpents, such as the Babylonian Hydra, the Greek Scylla and Typhon, the Scandinavian Thor, and Jormungandr, and the Christian Leviathan, defeated by Yahweh. Gradually, outline structures, forms begin to emerge from the chaos. In the main monument of Maya, Kish, Indian literature, and the collection of mythical stories of Popol Vuh, written in 1500 BC, the following is written. Out of a state of obscurity, of cold, of silence, the progenitors' great mother and great father, who were thinkers by nature, listened to the heart of the heavens, their God, and decided that at the coming of dawn, man, earth, and light should come into existence. First, the earth was created, mountains and valleys, like a mist, like a cloud of dust, was the earth at its creation, at the beginning of its corruption. Then, mountains appeared out of water. Great mountains grew instantly. The path of the water stream was pointed out. Streams began to run freely at the foot. In Japanese mythology, everything arises for similar reasons. After the umbilical cord of heaven and chaos broke, the chaos began to turn into a kind of disgusting and repulsive substance, resembling a jellyfish. Soon, deities emerged from its depths and decided to create something extraordinary that would dispel their longing and give meaning to their lives. These creations were Izanagi, the deity of male power, and Izanami, the deity of femininity. They had a difficult task: to transform the formless chaos into a beautiful world and populate the earth. Izanami and Izanagi stood on the heavenly soaring bridge and looked down where the black abyss bubbled and howled. They wondered, what is down there? At that moment, the supreme deities held out a magical jeweled spear. To Izanagi, they were destined to give chaos a shape. The gods set to work, and as they labored, the earth gradually took shape. From a single salty drop that fell from spear, Japan emerged. In various myths, creators are confronted with the indeterminate and limitless potential of chaos, not defined in space or time. At the moment of creation, ancient Australians conceived of what they called mythic time. In this mythical time, the totemic ancestors of the tribes created the present state of the world, including landscapes, celestial bodies, flora, fauna, and even patterns of economic, religious, and social behavior. Mythic time is portrayed as a period of primordial objects, actions, and creation. Ancient Australians likened it to the time of dreams, in which complex conjunctions of events occur. In dreams, a person can move seamlessly from one place to another without feeling a sense of discontinuity, as if the perception of time undergoes a profound shift. In mythical time, akin to the realm of dreams where tangible reality feels weightless, it's believed that primordial ancestors traversed the world, naming and shaping all aspects of existence. This era birthed the world as we know it. Yet, what becomes of chaos when harmony and form seemingly prevail? It persists. Like Jormungandr, the world serpent of Norse mythology lurking underground but destined to resurface during Ragnarok, chaos retains its potential to erupt and disrupt. Eschatology is the doctrine of the end of time, prominent in various mythologies, where hypothetical catastrophic events are often mentioned. In Hinduism, Kali Yuga marks the culmination of time, heralding the arrival of the final avatar, Vishnu, to purify the earth. The Book of Revelation in Christianity describes a sequence of events leading up to Armageddon, the apocalypse, culminating in the second coming of Jesus, the possible appearance of the Antichrist, divine judgment, and the dawn of a utopian world, devoid of sin. Paradoxically, although humanity has historically resisted chaos, one of its oldest archetypal symbols is Ouroboros, the serpent that devours its own tail. Ouroboros embodies a paradoxical existence, simultaneously energizing and self-destructive, engaged in auto-cannibalism, a concept that may have deterred other extraterrestrial civilizations from spreading throughout the universe. As humanity has yet to discover any concrete evidence of alien life or intelligence, we are left only with our own cultural narratives. To marvel at its anthropocentrism would be naive. In Hindu mythology, the genesis of the world is depicted through the sacrifice of a primordial man, Purusha, whose vision by the gods was necessary for creation. His life served as the sacrificial offering required for the world's formation, with the gods dismembering him. From his mouth emerged the Brahmins, the priestly class, symbolizing knowledge and spiritual authority. His hands became kshatriyas, warriors. From his thighs were created the Vaishyas, farmers, and from his feet were born the Shudras, the lower class, who were to serve the higher class. From Purusha's mind arose the month. From his eye, the sun. Fire was born from his mouth, and from his breath was born the wind. From his head came the sky, and from his ears the countries of light were created. In this way, the world acquires orderliness. The ordered world, the ancient Greeks called the cosmos. The cosmos already possesses empirical and comprehensible time. Today we know that abiogenesis, the formation of organic matter, occurred in water. The amazing and beautiful thing is that this was intuitive to humans long ago. Myths are so easily accepted by us because they are biological in nature, natural. Man, once long ago, having realized himself in a flat, still very poorly understood world, began to engage in myth-making, the addition of stories, ideological alchemy. These constructs help the man find himself, straighten his spine, and after a time of searching say, I am the main thing that happened to me. I am valuable. This is how man began to know the universe, through language. In the dawn of human consciousness, individuals began assigning names to objects, phenomena, and states. Across most languages, the name for our planet derives from goddesses associated with soil and fertility. For instance, the ancient Scandinavians revered the goddess Yoth, whose name eventually gave rise to the word Earth. Every myth traces its origins to ancient times. The distinctive characteristic of the primitive human psyche is its holistic nature, the fusion of natural perception with speculative and sensory understanding, blending the material with the figurative. In such a worldview, the division into objective and subjective for people simply does not exist. In the self-awareness of ancient peoples, there existed no entities or phenomena standing apart from reality in a realm of transcendent essences. Their consciousness did not allow for a separation of the world into distinct layers. Instead, they perceived their environment as intimately connected to humanity. Ancient people viewed the world through a holistic worldview, akin to wearing 3D glasses. They lacked a clear differentiation between the real and the ideal, with fantasy seamlessly intertwined with authentic events. Reality was generalized through sensory and concrete imagery, directly engaging with individuals. In this worldview, the collective held precedence over the individual, nearly eclipsing it entirely. The reproduction of this collective mental activity led to the development of structures aimed at transmitting collective experience in a manner compatible with primitive understanding. This form, which combined sensuality and emotionality with didacticism and comprehensibility and accessibility of assimilation with motivation to action, became myth. In translation from Greek, myth is a legend. That is, something that should be passed on to the new generation, should be cognized by it. Myth serves as a specific framework, a narrative shaping individual fiction, ideological concepts, and political doctrines. For tribal communities, myth transcends mere storytelling of natural human relationships. It embodies the most tangible reality, constituting the very fabric of existence. The timeline of cosmic and earthly events underscores the grand narrative of existence. 13.8 billion years ago, the universe came into being. Approximately 4.5 billion years ago, the Earth formed. Life emerged around 3.5 billion years ago, leading to the Cambrian explosion 550 million years ago. Around 65 million years ago, dinosaurs perished, paving the way for mammals to dominate the planet. Approximately 25 million years ago, the earliest great apes appeared in Africa. 10 million years ago, there is climate change, cooling, drying, shrinking forests where great apes live. Some of the apes remain in the forests, some go to the savannas. 2.7 million years ago, the Paleolithic begins. The first stone tools appear. Around 2 million years ago, the Pleistocene epoch, also known as the Ice Age, commenced. Approximately 200,000 to 400,000 years ago, great apes began utilizing fire across various regions. Between 45,000 to 100,000 years ago, the modern species of Homo sapiens emerged in Africa. Around 50,000 years ago, Homo sapiens began migrating and settling in Europe and Australia. The Upper Paleolithic era began roughly 40,000 years ago, marking a period of significant cultural and cognitive evolution. Art and musical instruments emerged, and some theories suggest a revolution in language grammar occurred during this time, enabling humans to articulate abstract concepts. As cultures emerged and evolved, competition among them intensified. This overview presents a condensed narrative akin to a scientific myth, a construct that is no less anthropocentric than Christianity or Hinduism. This perspective inevitably leads to the Anthropic Principle, a foundational concept in modern cosmology. The Anthropic Principle highlights the interconnection between the universe's vast properties and the presence of humans, who serve as observers within it. Observers are necessary for the universe to acquire existence. The author of this quote and the Anthropic Principle is physicist John Wheeler. He believed that the universe cannot evolve without an intelligent observer. Hence, only universes that are suitable for the emergence of life and intelligence are possible. Obviously, this concept grows out of the interpretation of quantum mechanics, including the observer as the verifier of the outcome of interactions in the microcosm. The famous Schrödinger's cat paradox and the two-slit experiment are devoted to this problem. The role of the observer in shaping our understanding of the universe is intricately linked to the phenomenon of wave function collapse, a complex and poorly understood aspect of quantum mechanics. Our perception of reality is further influenced by the values of physical constants governing fundamental forces such as electromagnetism, weak and strong nuclear interactions, and gravitational force. These constants, along with particle masses, are intricately tied to the properties of the Higgs field, yet their values are not derived from more fundamental principles. Rather, they are determined through empirical measurements. These physical constants play a crucial role in shaping the universe as we know it, and even minor alterations could have profound consequences. This is where the Anthropic Principle comes into play, both weak and strong versions. The weak Anthropic Principle suggests that the parameters of the universe are finely tuned in a way that allows for the existence of life. Even slight variations in these constants could render life impossible. For example, if the neutron were slightly lighter or the proton slightly heavier, the formation of complex structures and atoms would be hindered. The universe appears finely calibrated to support life, and this observation prompts questions about the nature of existence and the role of conscious observers within it. It would take a long time to list them. It is very similar to the history of our appearance in the solar system on Earth. As you remember, there are a lot of fortunate coincidences here too. The constants in our universe are infinite in number. Listing them won't get us anywhere. Another thing is more important. With the emergence of man, and then the information social process, culture, man himself became a demiurge, a creator of completely different worlds. One of the main statements of Plato: the visible is not the real. The idea that our perceptions may not accurately reflect reality is a fundamental concept in philosophy, one that Plato famously explored. To illustrate Plato's theory, let's consider a simple example. 3 fruits lying before us. While each fruit may differ in appearance, there is something common among them, a shared essence that unites them into a single category. We call this shared essence fruit. However, does fruit truly exist as a tangible entity containing all possible fruits from the earth, something that can be examined or touched? In reality, it does not. Fruit is merely a concept, a term, a linguistic construct that we use to designate a group of similar objects. It exists as an idea, a mental abstraction. Only the individual fruits themselves truly exist in the physical world. Their names and our understanding of them reside solely in our minds. But it may well be assumed that the opposite is true. First, there are ideas or the concept of things, and not in our mind, but by themselves, outside of us, only in a special higher world, inaccessible to us. And all the things that surround us are only the generation of these ideas. They are reflections. They are shadows. This idea is central to Plato's teaching. To us, the world seems to be one, the one we see around us. In fact, there are two worlds. One is the invisible world of ideas. The other, the world of things we perceive. The first gives rise to the second. The second gives rise to the first. To illustrate his concept, Plato created a separate story, a myth. Imagine that we are sitting in a cave with our backs to the entrance and looking at its wall. Behind us, in the sunlight, some animals pass by. Birds fly by. Flowers grow. The allegory of the cave, famously depicted in Plato's philosophical work, illustrates the concept of perception versus reality. In the allegory, individuals are likened to prisoners confined within a cave, their backs facing the entrance. They can only see the shadows of objects projected onto the cave wall in front of them, unaware of the existence of the objects themselves. To these prisoners, the observed shadows represent the entirety of reality. However, if one were to break free from the confines of the cave and turn around to behold the actual objects casting the shadows, they would realize the limitations of their previous perception. The real world, far from the illusion of the shadows, would reveal itself as infinitely more vivid and complex. This newfound understanding would inspire awe and a desire to contemplate the true nature of reality. Furthermore, venturing outside the cave would unveil an even greater expanse of beauty, a world of wide green plains, beautiful meadows, and an endless azure sky, illuminated by the radiant sun. This journey symbolizes the transition from ignorance to enlightenment, from the confines of limited perception to the vastness of true understanding. The ability to create an image, to perceive a symbol and tell a story, that is, to subdue the passage of time, is our main strength. The task of each of us is to see the genuine behind the false, the real behind the unreal, the ideal behind the material. But if we can visualize, imagine a world that is absolutely beautiful, refined, elegant, and lovely, why not try to ennoble the earth a little? Thanks for watching. Don't forget to share your opinion in the comments.